the book calls it improper, and I understand why it's improper. The degree of the top is bigger than the degree on the bottom. When you have this kind of a fraction, you have to do one thing before you can start writing or finding the partial fraction decomposition, and that is you have to divide it first. It's annoying because it's a lot to write, but there's not that many steps when you do it. We have x to the fourth, and actually all of them are kind of like this. They don't have a lot of steps. 2x to the third plus 6x squared plus 20x plus 6. And on the outside, we'll put our x to the third plus 2x squared plus x. Okay, so we look at the first numbers. What can I multiply to x to the third to give me x to the fourth? X. 1x, actually. And so I like to put that above my x term so that I know what I have to bring down next. And when I multiply that x to all of these, I get x to the fourth plus 2x to the third plus 1x squared. And then what you're supposed to do is you're supposed to subtract that, but I like adding the opposite better. So I just changed all the signs. That becomes 0, that becomes 0, and what I have left over is 5x squared plus 20x plus 6. That's my remainder. These are the two things you would bring down. And the reason why I know it's a remainder is because I can't multiply x to the third by anything to give me 5x squared. And so we have plus 5x to the second plus 20x plus 6 all over x to the third plus 2x squared plus x. So our answer is going to be x plus our ugly remainder, 5x squared plus 20x plus 6 over x to the third plus 2x squared plus x. And in order to finish this, this will be part of your answer, the x plus. In order to finish this, we have to take this and find the partial fraction decomposition of that. And so, I got to write it again. 5x squared plus 20x plus 6. And I'm writing it all the time a lot because I'm trying to be explicit and make sure you guys understand it. You guys probably might do this a little bit faster because it's your work and only you have to understand your work when it's your practice. Okay, we'll take this guy right here and factor it. We can take an x out. We would get an x squared plus 2x plus 1. And then we can factor this guy right here. That becomes the x plus 1 times x plus 1, which is also known as x plus 1 squared. That's gone. Alright, so what are my fractions going to look like? I'm going to have 3 of them. I'm going to have 1 for the x, 1 for the x plus 1, and then 1 for the x plus 1 squared. So we have our constants, a, b, and c. Now you have to find the a, b, and c. To find the a, b, and c, we're going to take all the fractions and multiply them by the lowest common denominator, which is x times x plus 1 squared. Okay, I'm going to start going up from here. Let's see, we'll have equals. When I multiply this times the very first one, not equals. When I multiply times the very first one, the denominator cancels out, and I'm left with 5x squared. And then we have 20x plus 6 equals a times something. A times what? Let's see. We cancel out the x because the x would cancel out. We'd be left with x plus 1 squared. And so it's a times x plus 1 squared. And then we have the b. The x plus 1 would cancel out, and I would cancel out that 2 right there to have b multiplied times x plus 1. Oh, dang, I ran a room. Oh, I can move this guy over. Let's move him over. Put you right there. Okay, and then the c, the very last one, will be multiplied times x because the x plus 1 squared will cancel out. We'll be left with the x. All right, did I lose anybody? A lot of stuff happened right there. To finish this, we got to pick x values just like before to try to eliminate some of these numbers so that we can solve for the others. Okay, so let's start out with the a. How will I get the a alone? What do I have to plug in to the x's so that I can solve for the a.
-1.
That means I have to make these ones 0. How do I make these ones 0? What do I want x to be? Yeah, I want x to be 0. If I multiply c times 0, obviously it's going away. If I put a 0 right there, that 0 will multiply times the b, and it will multiply times the x plus 1 and get rid of both at the same time. So, if I plug in 0, ooh, this one goes away, and this one goes away too. Dang, I like solving for a. So 6 equals a times 0 plus 1 squared, and 1 squared is just 1, so a equals 6. Oh, that one was so pretty. It was pretty. And just let me recap that. I want to say that again. Sorry for the video. We had to plug 0 into these x's also, which eliminated the 5 and the 20. That's why we only have a 6 right here. All right, now if I wanted to solve for b, what would I have to plug into that one and that one? -1? Yeah, -1 would get rid of the a, because a -1 plus 1 would be 0. But -1 would not get rid of the c. Ooh, this one's going to be a little complicated. So let's skip the b for a second and see if it's easy to find the c. How can I find the c? -1. If I plug a -1 in right there, this would be a 0. If I plug a -1 in right there, that would be a 0, and 0 times the x and the b would be 0, right? Right. Okay, so that's what we're going to do. Let's plug in -1 to all my x's. So I have 5 times -1 squared plus 20 times -1 plus 6 equals c times -1. Because remember, these ones got canceled out because -1 makes those 0. Alright, so this is what we got. We got a 5 right there. We got a -20 right there plus a 6. On the other side, we have a -c. Let's see. 5 and 6 is 11. So I have 11 plus -20. -20 and a positive 11, well, it could be -9. That'll equal -c. Well, that c looks like a 6. Let's change that. And then I get c equals 9. Positive, right? It's positive 9. Oh, okay. Now, can we find the b? Let's do what we said again. Alright, so now, to find b, remember before we said, oh, let's try -1. Would -1 work? See, if I plug a -1 there, it would cancel out, right? But then I'd plug in -1 there, that would make that a 0. Ugh. I don't want that to be a 0 because then I'll cancel out my b. So what do I do? 3? Why'd you pick 3? I don't know. I just pick numbers. That's just what I do.
Do you plug in A and C?
Yes, we plug in A and C. We have to plug in A and C, and then we have to plug in one more number for the x. Remember, x is our variable. It can be whenever we want it to be. You don't want 0 because if you plug 0 into the x right here, it'll get rid of the b. 1 would work. Because 1 plus 1 would be 2, and then I have a 1 right there, so let's do that. So let's plug in the A and the B. Let's see, the A would be 6, and we're going to plug in 1 for the X. And then I have plus B times 1 plus 1 plus C. No, wait, what are we plugging in for C? 9. 9 times 1. And on the other side, it's not that bad because we're just squaring 1. And then we're multiplying 20 by 1. And then we have a 6. Alright. Not bad at all. Alright, 1 squared is 1. I have a 5 right there. I have a 20 right there and a 6. 20 and 5 is 25 plus 6 is 31 equals. And then I have a 2 right here. 2 squared. 2 squared is going to be a 4. 4 times 6 is 24. Plus, that's a 2. So 2b. Plus... and then we have a 9 right here. Can you finish it? Yes. Okay, man, I'm like in a corner here. I have nowhere else to go. I move this up. Bam. Alright, so I have 24 and 9. 24 and 9 is 33 plus a 2b equals 31. Alright, next I would subtract 33 from both sides. Oh, I'm running out of space. Negative 2 equals to b. What does my b equal? Negative 1. All right, let's plug in a negative 1 right here. Negative 1. And the a, you're gone. C, you're gone. What was the c again? The c was 9. And what was my a? 6. All right, try to imagine those denominators not being crossed out. This is almost the answer. What am I forgetting? Yeah, I need that x in here. This guy. Plus x. This is your answer. I'm going to fix my denominators right here. Hey guys, this is as nasty as they get. The x plus comes from when we divided. And then all these fractions right here, if we were to add them up, we would get this ugly remainder. That is the partial decomposition fraction. There. Okay.